Namaskar. Today we will study thiazolidine diones. These are antidiabetic drugs, orally used antidiabetic drugs, uh, particularly in type 2 diabetes mellitus when there is insulin resistance. And let us first discuss what is this diabetes mellitus. Diabetes mellitus is a chronic metabolic disorder characterized by hyperglycemia, where the fasting blood sugar increases more than 7 millimole per liter, and 2-hour postprandial blood sugar increases more than 11.1 millimole per liter. And the hormone which is involved is insulin, because insulin is the hormone which helps in glucose transport into the cell and also regulates the glucose metabolism, stimulates glycogenesis, so glucose is converted to glycogen, inhibits glycogenolysis, inhibits conversion of glycogen to glucose, and inhibits gluconeogenesis, inhibits the formation of glucose from non-carbohydrate sources, and also insulin helps in lipogenesis, the conversion of free fatty acids to triglyceride, whereas it inhibits the lipolysis, conversion of triglyceride to free fatty acids, and it also increases the uptake of amino acids and helps in protein synthesis. So all these actions are there for insulin. And how it does this? Insulin acts on the insulin receptor, which is a tyrosine kinase linked receptor, following RAS-RAF pathway, and ultimately it regulates the gene transcription, and where it does all these actions what we have already discussed now. So all these processes involved enzymes, and these enzymes are nothing but proteins. Even this glucose transporter is also it is a carrier protein. So all these proteins are involved in these processes, which will decrease the level of glucose. And proteins means there is a gene or DNA. So DNA to RNA, that is the process of transcription, then RNA to protein. So DNA or gene is converted to RNA, messenger RNA, that is the process of transcription, then RNA, then process of translation. So there will be use of transfer RNA, and we will have this protein. So if this protein synthesis is regulated, that means some proteins are activated and some proteins are inhibited, then for example, say glycogenesis is the process where glucose is converted to glycogen. So these enzymes, if stimulated, then glycogenesis will be stimulated. That means all those enzymes or proteins, their gene transcription has to be stimulated. So that is caused by insulin. And similarly, the enzymes involved in glycogenolysis, their gene transcription is inhibited. The enzymes involved in gluconeogenesis, their gene transcription is inhibited. And the enzymes involved in lipogenesis are stimulated. The enzymes involved in lipolysis, their transcription is inhibited. So all these things are there. And when there is insulin resistance, that means insulin is there, but insulin is not able to do its function through this gene transcription. So that condition is called insulin resistance. And in case of insulin resistance, what happens, whether it is insulin resistance or fasting condition or during starvation or due to heavy exercise, due to the absence of glucose, it will promote the fatty acid beta oxidation in skeletal muscles, and this fatty acid beta oxidation becomes a key source of energy, and this inhibits phosphofructokinase, and because of that there will be accumulation of substrates from previous stages including glucose 6 phosphate, and glucose undergoes glycolysis where glucose is converted to pyruvic acid, glucose is converted to glucose 6 phosphate, then further process involved to convert it to pyruvic acid, then pyruvic acid is converted to acetyl coenzyme A, which will undergo this Krebs cycle to produce ATP. Okay, so this fatty acid beta oxidation will accumulate the substrates from previous stages including glucose 6 phosphate, which will inhibit this process of glycolysis. This is called glycolysis, glucose to pyruvic acid, and because of that there is also decrease in glucose uptake, and no glucose will be uptaken by the muscles. So insulin resistance decreases the glucose uptake, and in that case there is another receptor which increases the sensitivity of insulin, which does insulin like action, that is this PPAR gamma, peroxisome proliferation activated receptor. It is of three types: alpha, gamma, and NUC is another one. Alpha is involved in your lipid metabolism. So the drugs like fibrates are the PPAR alpha agonists, which are used in hyperlipidemia, and PPAR gamma agonists are antidiabetic drugs. This is a nuclear receptor linked to retinoic acid receptor. So when the thiazolidine diones, these thiazolidine diones are acting as agonists, pioglitazone, rosiglitazone, they are acting as agonists on this receptor. When they bind to this receptor, there will be a activation of these thiazolidine response elements or PPAR response elements, and there will be gene transcription. So again these are linked to this insulin response elements also. So there will be gene transcription which ultimately will decrease the sugar level. And how it does this, let us discuss the detailed mechanism. So thiazolidine diones activate the PPAR gamma receptor, and this causes the transcription of PPAR response elements or thiazolidine response elements, and this causes adipose cell differentiation. So adipose cell differentiation will lead to formation of these adipocytes from pre-adipocytes. These adipocytes secrete adiponectin, and this PPAR gamma activation also increase the expression of PPAR gamma angiopoietin related genes, which increases the angiogenesis, that is blood vessel formation. So blood supply increases, so there will be adipose tissue development. So more the adipose tissue development, there will be more secretion of adiponectin. This adiponectin activates AMP activated protein kinase AMPK, which stimulates lipogenesis, conversion of free fatty acid to triglyceride, and inhibits lipolysis, conversion of triglyceride to free fatty acid in adipose tissue. So this decreases the circulating free fatty acid level. So when there is high free fatty acid level, that inhibits actually glucose uptake. So by decreasing the free fatty acid level in the skeletal muscle, the glucose uptake in muscles can be increased through GLUT4 expression. So when there is circulating free fatty acid level decrease, that increases the GLUT4 expression and increases the glucose uptake in the muscles, and this reduces the blood sugar in insulin resistance. So these drugs can be used in insulin resistance, and they act by decreasing the free fatty acid level, and when there will be less free fatty acid to compete with glucose uptake, so that will increase the glucose uptake in skeletal muscles, and that decreases the blood sugar level. So these thiazolidine diones increase the sensitivity of insulin. Even though there is insulin resistance, these drugs can decrease the sugar level. So these drugs are also known as insulin sensitizers. And thiazolidines can be used in case of type 2 diabetes mellitus with insulin resistance. However, these drugs have major side effects like there is risk of heart diseases, myocardial infarction, congestive heart failure, there is risk of liver toxicity, hepatotoxicity, and there will be fluid retention, edema. Because of that, there will be weight gain. And some of the thiazolidine diones like rosiglitazone is withdrawn from the market because of toxicity, cardiotoxicity. So the most commonly used thiazolidine dione nowadays is pioglitazone. So these are some of the examples. The first thiazolidine dione or glitazone, we can say, glitazone is cyglitazone. Others are rosiglitazone, N-glitazone, troglitazone. The most commonly used nowadays is pioglitazone. So these thiazolidine diones are contraindicated in hepatic failure, pregnancy, lactating mother, children, in case of congestive heart failure, in obese patients. So in these cases, thiazolidine diones should be used cautiously or should not be used. So this is all about thiazolidine diones. Thank you.